In last section, we discussed about cascaded OPAMP or telescopic cascaded OPAMP, and we found that there is a drawback in telescopic cascaded single-ended operation. It's that it cannot act as a buffer amplifier, or the output and input of the telescopic cascaded OPAMP cannot shorted together. It can short, no issue, but the output swing is low. So here we will derive that one, and next we will discuss the folded cascode, and we will finish this session. And if we consider a telescopic cascade op-amp, here diode connector configuration for, or the current mirror configuration for getting single-ended output, and here we are assuming that input and output are shorted together. And to evaluate this, we need to find the output swing, how much this output can vary. The basic idea is all transistor, all MOSFET must in saturation to act as a differential amplifier or a op-amp. Here we are considering M4 and M2, the saturation condition of M4 and M2, to derive the output swing of this telescopic cascade op-amp in buffer mode. So here if we consider M4, this VD, the saturation condition is VDS must greater than VGS minus VTH, or we can simply write the value of VD must greater than VG minus VTH, because sources is common, we can cancel each other. So in case of M4, that condition, the Vout must greater than, in this one it is gate is B, so VB, and the threshold voltage I am writing it as VTH, for I am not considering identical MOSFET, so it is VTH4. And with respect to this one, that M2, the drain voltage is Vx must greater than, its gate voltage is Vout minus VTH2, or from this one we can write another equation like Vout must less than Vx minus VTH2. And what is the value of Vx? What is the value of this one Vx? This Vx is nothing but Vb minus VGS4, or Vout must less than Vb minus VGS4 minus VTH2. So this will be the first equation, and this one will be the second equation. And if we compare this one, we can conclude that this will be the maxima value of output, because output is limited by Vout must greater than this one, so this will be the minima value of output, and this Vout is always less than this one, so this will be the maxima value of output, Vmax, Vout max. Okay, so if we find the swing Vout max minus Vout min, you will get it as, we need to subtract these two, the base where VB will cancel each other, and from this one we are subtracting this one, so it's become VTH become positive, VTH4 become positive, minus VGS4. I have a mistake, I think I made a mistake here that is positive. Okay, when this come in the right side it is positive, it is minus of VGS4 minus VTH2, or we can rearrange this one as VTH2 minus VGS4 minus VTH4, or this is equal to, This is equal to VTH2 minus V overdriven voltage of the MOSFET 4. So this is the maximum swing that we can provide, and it is always less than a threshold voltage itself. That means output swing is very low. We cannot use that buffer. We cannot use that as a buffer amplifier. Okay, that's a drawback of single-ended telescopic op-amp. And this one is a modified structure to improve the output swing of single-ended configuration. Here, the feedback, the current mirror configuration is obtained by from M7 to M5 itself, and we are using an extra biasing VB2. Using this one, we can improve the output swing by an extra threshold voltage VTH. That's the maximum threshold change or the output swing change we can achieve. Okay. Earlier it is VTH2 minus a overdriven voltage. Now it's become 2 VTH minus an overdriven voltage of the 4 will be there. Or VO4 overdriven voltage. Overdriven voltage is gate source minus threshold voltage. And it's a triple cascode, and I said we can cascode any number of stages where the resistance value will become huge. Here it's shown it's become R raised to 3. If we are using 4 stage, it become R raised to 4, etc. It will be there. But the main drawback is each MOSFET require a overdriven voltage to keep that MOSFET is in saturation. So each MOSFET require a overdriven voltage. Here I forgot VDD. So due to that, the output swing decreases by twice that of the overdriven voltage, because there will be an extra overdriven voltage in the upper half as well as lower half. The symmetric addition is required to improve the gain. And the last topic is folded cascode op-amp. Here also we need to by heart, or we need to remember the circuit diagram. Okay, no other thing is there, because analysis are same as that we did in earlier cases, or the values are almost the same, no issue, but the circuit is very important in analog CMOS circuit as well as CMOS design. You need to draw the circuit and its small signal model. If it is there, you need to draw that one. Okay, so circuit is very important. If circuit is wrong, means you will not get any mark. So folded cascoded configuration. The cascoded configuration, we are just folding instead of cascoding, stacking together. We are separating the input stage. That will improve our output swing. That's all. And for separating or folding out the input from the cascaded stages or the load, we need to use another configuration like this one. Here the PMOS circuit is used as the input element. That's all. So this circuit also will give the same response as that of a normal cascoded configuration. And the important thing is that due to the separating out of this MOSFET, input MOSFET, the overdriven voltage, the effect of overdriven voltage is reduced, or the output swing increases. Output swing increases. So if we are separating out the input stage, we don't want to consider these many additions in the lower half. Okay, so that much overdriven voltage we can save, and we can increase the output swing. So this is a folded cascoded configuration of differential op-amp. Okay, or cascaded op-amp. In this cascaded op-amp, just look into this one. We are adding a lower number of stages in the upper and lower stage, and there is an improvement in output swing. Okay, well, that output swing due to the input op-amp we can neglect. Overdriven voltage of that input op-amp we can neglect. No stacking issue. Buffer configuration is possible. Buffer configuration is possible in this one. Okay, buffer configuration, input to output shorting is possible in this one, because there is no stacking issue. There is no stacking between input and the load side, so we can connect output and input together without affecting the there will be effect in the overdriven voltage, or the sorry, not overdriven voltage, output swing, but we can use that output swing to implement circuit. I think that's all. Here also the gain calculation of this folded cascoded configuration. In this folded cascoded configuration also we are performing same step as that of the previous one. Here also we are considering half circuit symmetry, and one half we are considering this one half. This one half we are considering for the analysis. Here we are considered that one half to analyze, and this one indicating the current source. Okay, this is the current source. Here it is current source. Here we are giving input only in one of the transistor V in 1 only. So the effective current is only from this input, and the transconductance value, effective transconductance value Gm become Gm1 itself, and output calculation is same as that of the previous case, except in the previous case this RB, or in RN, RN we notated, right? In RN we found that this resistance at this point is only R0N or R01, but here it is a parallel combination of R0N and, or here it is R0N1 and R0N5. This parallel combination is there, and the effective RB value or RN value becomes GM3 R03. GM3 is from here multiplied with its resistance value and into this resistance value, that is R01 into R05, R01 into R05. So the effective gain, there is no variation in gain, but we will get a somewhat improvement in our overdriven or output swing, not overdriven voltage, output swing, because we are avoiding the overdriven voltage due to supply. That's all. Okay, that's all for this session, I think. Okay, we discussed cascoded OPAMP, telescopic cascoded OPAMP, and then we modified the telescopic cascoded OPAMP with a single stage output using diode configuration like this one. Single stage configuration, single-ended output. And next, the drawback of that one we discussed, it is we can use as a buffer amplifier, or it have a shorting issue between input and output. To solve that, we to improve that one, we used a modified telescopic cascode configuration, and also improving the output swing, we used a folded cascode configuration. Okay, that's all.